All right, hello folks. So what we're going to be looking at here today is section 3.3 from your textbook involving properties of lines, or properties of slopes of lines, I should say. So with this, there's not much notes to take down, but we're going to do this together. So what I would like you to do while you're watching this video is to have Desmos handy. Either you can open it up in a second tab in your browser, or if you have a phone or tablet handy, you can open up Desmos on that. We talked about Desmos earlier in the year. That's our graphing calculator app. So I'm going to pull out Desmos right here on my browser, desmos.com/calculator, and I'll be bringing this in and out so you can see what we're doing. So the first thing we're going to do is I want to compare these four lines that I have on here: y equals x, y equals 2x, y equals 3x, and y equals 1/2 x. And we're going to enter all of those into Desmos. So let's go ahead and do that. If at any point I start going past you, go ahead and pause the video so that we're doing this together. So my first line is going to be y equals x. I just want to get a sense of what lines look like. So this is about the basic, most basic line we can have. This is what's called the parent function, y equals x. And we can see that we have a nice 45-degree line, essentially, going up and to the right. What I want to do is I want to change the number in front of that x value. And I want to see what happens to my line as I change it. Remember, the number in front of the x is our slope. So that's what we're playing with right now. So in the second line, I'm going to enter y equals 2x. And what happens to my line there? Well, you can see it's in the same position. It's starting at 0, 0, just like the first line, but it looks like it's now steeper. It's angled more up. Let's try y equals 3x, and it does the same thing. So it looks like the bigger I make that number, the steeper my line is going to be, right? If I were to go do something crazy, y equals 55x, you can see I have nearly a vertical line there. So the bigger the number, the steeper the line appears to be. What if I were to go the other way? That fourth line I had is y equals 1/2 x. So if I have a bigger number, it made it steeper. So what if I went less than this slope here? Remember, this number, what's in front of the x, is a 1. We just don't write it. So this line, my first line, has a slope of 1. So what if I go less? So if I go y equals 1/2 x, we can see now it's a more shallow line. Let's go even less. Y equals 1/3 x, more shallow still. So it looks like then the smaller the number, the more shallow the line, the steeper the number, the steeper the slope, the steeper the line. It does not change the y-intercept, however, right? All of these, if I find my tab again, we can see all of them are passing through the origin. So all I'm doing there is affecting the steepness of the line. I didn't have any negatives though. So now what happens if I add some negatives in? So let me bring back my Desmos. So let me get rid of all of these. And let's enter these. So y equals 2x. We saw that one before. It's a little bit steeper than our parent function. What if I turn it negative? So let's compare that against y equals negative 2x. Well, you can see here that line is just as steep as the first one, but now it's going down instead of up. So instead of going up and to the right, it's going down and to the right, but it's the same steepness, it's just the opposite direction. Let's try those other two. Turn those off. Let's try y equals 6x and y equals negative 6x. And you can see the same thing happens. Those lines are equally steep, but the negative line is going down, the positive line is going up. So to answer this question, describe the lines with respect to the slope. They're the same slope, but they're going in the opposite direction. That's what the negative in front of your slope does. All right, now let's start at changing that second number. So we'll use that y equals 2x again as our example. So I'll clear all these off. Let's enter y equals 2x. So there's that line. You can see it's passing through the origin, a little steeper than our standard line. Now let's do y equals 2x plus 3. What happened? Well, that line you can see is parallel to the first one. It's equally steep, but it's just a little bit higher up. It's been shifted upwards. We can see our y-intercept here is 3. Well, what if I do y equals 2x minus 3? Well, now we can see again equally steep. However, now I've shifted my line down. So our b value is our y-intercept, if you recall from previous lessons. So all we're doing here is we're moving that line up and down. Here, let me show you something. So if I were to say y equals 2x plus b, in Desmos, you can see I can add a little slider. So I'm going to press this, and now I can change what b is. So as I change my b value, you can see I can literally slide my line up and down on my graph. So the bigger the b value is here, the higher up the line is going to be. If I go lower, the lower down my line is going to be. But notice the slope, notice the angle. It's not changing because the angle of the line, the steepness of the line, is controlled by my slope, controlled by that coefficient in front of x. In this case, it's 2. I'm not changing that. I'm only changing the b value, the y-intercept. So the slope controls the angle of the line, the steepness of the line. The y-intercept is going to control its location on the graph, but it does not change the steepness of the line. That's what I want you to pick up on there. So ideally then, when I give you a line, we should have a rough idea of what it's going to look like, and we'll see that more and more as we go through more lessons. Now, let's get into some special cases. In the case of a horizontal line, horizontal going perfectly flat, what would the slope of this line be, or the equation of the line? Well, let's start with the slope. Now, we learned how to do slope the other day. We know our slope formula is delta y over delta x. So I can choose any 2 points on the line. It doesn't matter which two. I'm going to choose this point here, which is the point 2, 2. And I'll choose this point right here, which is the point 8, 2. So remember what we do for slope. It's y2 minus y1 over x2 minus x1. So let's plug in our values. The y-coordinate of point 2, the y-coordinate of point 1, so 2 minus 2, over x-coordinate of point 2 minus the x-coordinate of point 1. So I get 0 over 6, which is 0. So my slope there is 0. Now I chose those 2 points randomly. It could be any 2 points. It doesn't matter. Let's try this again. Right? What if I chose, let's say, this point, which is the point 4, 2, and this point over here, which is the point 5, 2. Well, when I do my slope here, I'm going to do 2 minus 2 over 4 minus negative 5, which is going to be 0 over 9, which is 0. It doesn't matter which slope I choose, I'm always going to end up with a slope of 0. And the reason is my numerator is always going to be 2 minus 2, because every y-coordinate on that line is 2. So because every y-coordinate is 2, the equation of the line is just going to be y equals 2. We know the equation of a line is y equals mx plus b. So we can see what the y-intercept here. We can see the y-intercept is 2. So my plus b, that's 2. And my slope, I figured out twice, is 0. So y equals 0x plus 2. Well, 0 times x is just 0. So this whole thing just becomes y equals 2. Any horizontal line will always have an equation that looks like that. It's just going to be y equals some number. If I were to take my line and say move it up here, this one would have the equation y equals 8. If I were to move it down here, this would be the line y equals -7, because every y coordinate is -7 on that line. For a vertical line, we can go through the same idea. So I'm going to pick 2 points randomly. Doesn't matter which point I choose. I'm going to choose this point, which is at 5, 0. And I'll choose this point, which is at 5, 4. Now, at this, with those 2 points, you can see the x-coordinate is 5 for both of them. And then no matter which point you choose, you'll always have an x-coordinate of 5. Now, if I try to calculate my slope for this one, y2 minus y1 over x2 minus x1, I have 4 over 0. Now, if you try to plug 4 divided by 0 into your calculator, you're going to get an error, because in math, we cannot divide by 0. This is what we call undefined. Okay? We're not allowed to divide by 0, so it breaks the math, right? We get an error in our calculator. So we can't quite figure out the equation of this line in the same way. But using some of the logic we talked about from a horizontal line, let's think about this. Well, in the horizontal line, every x-coordinate, I'll move my line back up here, every y-coordinate was always 2. So we just called this line y equals 2. For a vertical line, every x-coordinate is going to be 5. No matter which point I choose on this line, it's always going to be 5 something. So I'm just going to call this line x equals 5. Okay, a little bit different than any other line we've done, because every other line has always been y equals something. But for a vertical line, it's a special case. It's going to be x equals some number, and that number is going to be the x-coordinate of every point on that line. Okay, so let's see if we can put this all together. What do I want you to take from this lesson? All right, so first off, if the slope is positive, it goes up and to the right. If the slope is negative, it's going to go down and to the right. So we know the direction that the line is going. No matter what, positive or negative, the bigger the slope number, the coefficient in front of x, the bigger that number is, the steeper the slope is going to be. So 2x, 3x, 4x gets steeper, steeper, steeper. Negative 2x, negative 3x, negative 4x. Steeper and steeper, but going in the opposite direction. Those special cases, a horizontal line has a slope of 0. A vertical line has an undefined slope, because we cannot divide by 0. And as we saw, if slopes have the same, or if lines have the same slopes, they end up running parallel to one another, like train tracks, so they're never going to cross. These are the 4 big takeaways from this lesson. If we understand this, you start getting an idea of what every line is going to look like, right? So if I were to give you a random line, y equals 3x minus 7, I can start thinking about this in my head and saying, okay, well, if my slope is 3, I know it's going to be a little bit steeper than 45 degrees. And if my y-intercept, my b value is -7, it's going to be down here somewhere. So I might have something like this. This is just a rough sketch, but my line should look something like that. So when I go to graph it, if I mess up my points, I have an idea of what the line should look like, and I can catch any errors that I might run into. All right, so that's where I'm going to leave it here for 3.3, guys. Page 124 are your practice questions. Some of these questions you might need graph paper for, or you're just answering questions because they give you a graph. For number 6, I highlighted that one because you are going to want to use Desmos or a graphing calculator in order to help solve that. Off you go. Let me know if you have any questions.